Thanks everyone for coming to my talk, which is an architecture talk. Profound impact of a lightweight API gateway written in Clojure. You can lead a zebra to water, but can you make it drink? And it's a zebra because I couldn't find a Creative Commons horse picture, but I found a zebra one instead. So this is kind of me acting as an ivory tower architect, and I realise I'm talking to all you people here who are IT professionals of one kind or another. And like most ivory tower architecture, you'd just be like, well, you've just put a bunch of boxes on the screen and said this is how things should be. And I'm like, how do I do that? How do I get there? You've described an amazing architecture, but I've got this 35-year-old mainframe system that's been running since the 1970s that still uses punch cards. How do I get from there to your new, interesting system? And this is what this is. This is about trying to describe what sort of steps you might be able to take that encourage people to do that. And rather than architecture being this, as Rebecca was talking about this morning, this sort of thing that you defined, it's how is it more about a conversation and about something that enables change. I'm going to use a fictional retailer, which I'm going to call Pargro, and no other reason than it means partial groceries, and Amazon bought Whole Foods, so it seemed appropriate. So this Pargro company, they've gone online, like everybody else has had to go online, but they're experiencing some problems now. Their pace of change is slowing. They're not able to deliver for their business. They've got a sales team that are complaining about not being able to sell organic vegetables online. They can't get these new products online quickly enough. And they've got an accounts team who they're saying that, well, we're sending out invoices to customers, but they're not actually the same as what the customer was paying. Like, why? We need to fix that, and we need to fix it quickly. And we've got a fulfillment team who's just screaming out to say, look, we need picking locations, and we need them as quickly as possible because the warehouse is just going absolutely crazy. So, based on the people that were complaining, the CIO managed to persuade all those people that were saying, oh, we can't get these things done. Well, why don't you be the product owners of these teams to get them to do the things that you know the business needs? But in doing the split, they created some fairly naive interfaces that were they're web APIs, but they're focused on really just creating some data or putting some data somewhere, and then somebody else is fetching that data, or they're just updating it. The fulfillment PO is suddenly telling a team, it's like, team, panic! We've broken production. This is a blocker alarm going off. And the devs are like, all right, what's gone on? What's happened? We've broken payments. Hang on. We're the fulfillment team. We pick things in the warehouse. How have we broken payments? We have nothing to do with payments. We don't touch the payment data. Well, accounts can't handle the payment capture anymore. They're telling us we're not giving them the data. It's like, well, why are we giving them the data? It doesn't make sense. But it turns out that in a sort of traditional approach of where you have a purchase order, and that purchase order consists of order line items, and you have prices associated with them, and you sum all those up, and there's some tax in play at a point in time. Those prices are agreed with the customer at a point in time. And the description of the articles that the customers bought, that's those articles at that point in time. So that data needs storing somewhere, that history needs to be captured, and it turns out that in splitting their monolith, Pargro have had the fulfillment team hold the record of order history. And worse still, they have the invoice team get the data from the fulfillment team so that they can then invoice these items. So this is a web API for submitting an order. Like the checkout team posts to this API, and it's been written in Java, and anybody that's familiar with Java will recognize this sort of thing. A lot of annotations which do magic. But on there you'll see there's an attribute called customer order. And this is where all these things at checkout get submitted. This contributes the customer order, all the items that they've ordered, how many of them, how much it costs, what the tax is, what they've paid. All kind of goes into that attribute. So it looks simple, but it hides quite a lot of complexity. The invoice team uses a similar thing, but just to fetch it. So this is a get endpoint, and they provide the order number, and they fetch the things, and again, in code, it looks very, very similar, and it responds with this customer order objects with all the data in it that the invoice team should need. There's like hundreds of attributes in this thing, and there's part-whole relationships. It's actually really complex, and it's just been sort of masked in a bit of code hidden in this customer order object. And the blocker that they're experiencing is this thing to do with payment data. And it turns out the payment data just simply looks like this. There's nothing to it. There's no behavior. There's just some attributes that are being captured. It turns out that the blocker is just that they're missing an attribute. And after a conversation with both the checkout team and the invoicing team, the devs quickly figure out what the attribute is that's missing and add it in. And deploy this new code into production. There's now 6 attributes instead of 5, and all is well with the world. But it's poor encapsulation, really. That's all this is. So one of the devs starts talking and says, well, we mostly deal with either checkout for taking orders or giving order history, or we deal with invoicing, who are getting things from us. And we're tripping on each other's toes at the moment while we're coding because we're having to do lots of merges every time we make some changes. So we'd like to split this thing into 2. On the promise of being able to deliver more by going faster, the PO sort of sits there and goes, yeah, you know, it's going to be okay to break this thing into 2. I'm going to tell like the other teams, the checkout team and the invoice team, that it's all going to be fine. These are just internal changes. We're not changing our interfaces. It'll all be okay. So the split happens, and the attributes of data are moved around by the team, because they just consider them to be internal, and they think, right, well, the checkout people have still got all their checkout information that they need, and the picking people have got their picking information. But the inevitable thing happens. It goes into production, and it's broken again, and the checkout people are complaining, you broke us again. And it turns out that this stock availability thing, which is like, why the people didn't check out, why are they interested in stock availability? They were using it to give an indicator, a prediction of when they were going to deliver. So if there was no stock, they'd know that they'd have to get it replenished and delivery would be next week. But if they have got stock, they could make a promise that the delivery will be in 1 to 2 days. Understanding the contracts between your team is crucial. And that's generally been an architect's role, that they are involved in those conversations and then they know kind of how the system is going to change or how its behavior is going to change. But as I'll come on to later, and as Rebecca said, it's important to try and test those contracts, have some way of being informed early and quickly if you're going to break them. One of the things I've seen other teams do at this point is instead of exposing their internal models, they transform them into something called DTOs, data transfer objects, and people are familiar with that. That's certainly one way to go about solving a problem, but it can often introduce another issue that you've got this anemic internal data model that you're having to maintain, that now you also have to maintain some DTOs when there's a change that needs doing, and now you have to maintain some code that does some transformation between the two. And probably there's a little bit of complexity happening there, and you've also written some tests about making sure those transformations work properly. So you've just increased the amount of code without really delivering any value to the business. So, if explicit API contracts are good, how is it Pargro have managed to make them a disaster? The technical architect comes along, she's heard a bit about the things that have gone wrong in production. So like a good ivory tower architect, she imposes Swagger code generation on her teams. The team went off in Pargro and they dutifully implemented Swagger code gen clients. It turns out that as the POs decided that they needed to get together and kind of understand what was causing them to slow down, why all of a sudden are the dev teams all just having to talk to each other all the time? And they kind of figured out, like, well, let's just get together, let's work out our priorities, let's list them on the wall. So they kind of listed out all their prioritizations by sprint and began to map out, like, which of their things depend on things in other teams. And it turns out there's quite a lot of these dependencies that they were mapping back and forth. The fulfillment PO that we've been talking about so far and her devs, they kind of started to have a conversation and think, well, do you know what, why is it with this payment thing that's been causing us so many problems. We've had this payment data object. It's caused everyone to break so many times. Why do we even have it? Why can't the invoice team just get it directly from the checkout team? Like, who really owns that data? We don't own it. It's not ours. We don't do anything with it. We have no behavior around it. In that profound bit of enlightenment, they realize they just need to rename their team. Because this is what they are. This is what they've become. They are the shared Oracle database of their retail enterprise. They have this idea that comes from the paper-based purchase order that people used to get given, where I take that purchase order, which is a list of all the things that's been handwritten out carefully and a price put on the bottom, and the person who wants to buy hands that to the seller, and the vendor then goes, yes, I agree, for that price, I'm going to give you these things, and then promptly puts it in the filing cabinets, and that's where it stays for the next 6 years. And that means that the fulfillment team, in this example, has all the same problems as anybody else that's integrating their systems via a shared database. It's the same when you are doing this, but in the NoSQL world, or you're pushing JSON data at people. And if you don't sort of obey Postal's law, and you start sending all this data in, and the people that are receiving it don't really know what some of it means, and don't really know what effects it's going to have, because there's other teams that are depending on getting that data from you, you have exactly the same problems. It doesn't matter that it's NoSQL. So we've got this fulfillment team in Pargrove. They're experiencing quite a few problems. They've got this poor encapsulation, these anemic object models that are very brittle, and every time anything changes in the business, someone's got to just go in, and it's not an interesting change, it's not a valuable change, they're just changing some names or adding a name. They're exposing that internal model over their web API, which means that every time they try and make an internal change to their system, they break the outside world. They've tried to solve some of these problems by putting this Swagger code gen in for these explicit contracts, but now that's made everyone tightly coupled, and it's really slowing down delivery. Nobody's getting any work done. And finally, this lack of data ownership, this having order fulfillment just own all the data, are bringing these shared database problems. So I hope to sort of demonstrate how thinking about a bit of architecture can help with this. And I know this is the most overused internet meme ever, and I'm sorry, but I couldn't think of anything else which would describe the problem now that the fulfillment team are in. Because obviously the devs have sat there, they've thought about these, they don't understand all the problems that they've got, and they're just saying, we need to change the world. We've got to change all these things. We're going to need time. At least, a couple of months to make all these changes so that we can start delivering again. And the PO responds with, like, you have no chance. The CIO has just had us pause for 2 months while we split everything so we can go faster. There's no way that either she or the business is going to accept us sort of pausing delivery again. And the devs are, well, if we don't do something, we're just going to slow down and stagnate, and we're not going to be able to deliver anything. We're already breaking the system twice a week. The devs sit down and have a conversation, think, well, do you know, the thing that we probably should do is we should wrap our system with a lightweight gateway. Because at least then we can protect ourselves, we can change our system internally, but everybody else that connects to us is still connecting to the same thing, and we shouldn't break them if we do that. So what sort of things do we need our gateway to do? Well, obviously provide something that wraps our system and allows us to proxy these published endpoints that we briefly showed earlier to our internal systems. And we should do that in a sort of one-to-one correspondence. And that gateway probably needs to publish these Swagger docs still. Everyone's still depending on it. Everyone's still generating these clients. So we still need to be able to support that. And we need to be able to vary our APIs. If we publish a new version, we publish version 2 of the order submission, how do we then map that to our new internal service? Well, in our gateway, actually, this is the only time that we think we'll allow a bit of extra code, a bit of business logic, because we can use it to transform that data so it conforms to our new internal service, but keeps the outside world still looking the same. This seems okay. And in fact, if we have a gateway, could we just provide the gateway as a little item on its own for other teams to test against? And then finally, can we do this newfangled thing? Consumer-driven contract tests. because they kind of sounded cool. And the invoice team wants to do it. The devs, they get together to kind of decide, now that they've kind of had a think about what this API gateway thing should look like and what should it be able to do and how is it going to help them, they get together to think about how they're going to make that work. And one of them pipes up, well, could we use HA proxy? That might be easy, because that will route from one endpoint to another. And someone said, well, yeah, but you couldn't host your Swagger docs on HA proxy. Oh, okay, well, what about Nginx? Could we use Nginx? Well, yeah, that will host the Swagger docs, and you can also do some layer 7 proxying, and that'll be all quite nice, but none of us really understand Nginx. That's like an infrastructure thing, and we're all devs. Well, yeah, okay, so why don't we just write it in code? I mean, that sounds easy, right? That's what we do. We write code, and that should be fine. And then some wag on this Java team pipes up, why don't we do it in Clojure? Everyone's like, what do you mean Clojure? That's that like ridiculous thing with all the brackets. Yeah, but it's good at transforming big data sets. So you have like small functions that handle this sort of big sets of data, and we seem to be dealing with lots of kind of big sets of JSON data. So why don't we give it a shot? So the PO sensibly decides, well, I can't stop delivery. Everyone still needs to be working, but I will carve out a week for a pair of devs to do a spike. Does everyone know what a spike is? More or less, a few people not nodding. So it's just simply a way of de-risking implementing some work. So if you're unsure about how to do something, can you just answer a few simple questions in a short space of time by just trying it? In this case, the devs want to know is, can Clojure be used to create a gateway that works for everybody and answer this question of like solving these problems? It's simply to say that their spike comes from this. This is taken a consumer-driven contract test. This is a contract. It describes an interaction. And they use it, and they map that. Just simple data transformation. All we're doing is running like a little function to transform that data into some different data that describes a resource. So a web resource, that resource being the order that's being created. But it uses this library called Yada from a company called Juxt. It's excellent. Instead of the Java idiom being you write a method which kind of accepts a request that comes in from the web, and then you do something with that, and it's like a function that executes. Yada is it's data that describes the resources instead, and things get matched to it, and then it will return a simple function based on a decision, but your function then is just the simplest thing in the world, and you don't really have to worry about how the web works. And in the case of the gateway, the function is always the same. It's like, pass the thing on. So it kind of worked very well for this. So just to visually compare, once the consumer-driven contract test has been changed into a resource, this is like the resource description, and it looks fairly complex in Clojure. Like there's a lot of things there. It's just mostly though the descriptions of these attribute names, the things that are passed in. And if we compare that to the Java thing looks really simple in comparison. It's a lot smaller, a lot more succinct, but it's got that customer order class, and that customer order class actually looks like this. It's got all this complex hierarchy that's kind of hidden and it's difficult to see, and if you want to go looking through it, you have to keep swapping from one class, which is usually one file, to another. Clojure is very simple in that really you've just got hash maps and vectors and lists or sequences, and that's all. And the functions that manipulate those are very, very powerful, and they're very good about doing it over large data sets. So the PO's happy. Says, let's build it. Let's go ahead. So it turns out that this payment thing has cropped up again. And the accounts team are telling the fulfillment team, like, I need a new payment field. And the fulfillment PO is saying, okay, well, let's have a chat with the devs about this. And they kind of look at the data that comes in about payments, and then they look at the data that the accounts team are fetching about payments, and it's clear now, because they can look in this gateway, and they can see these two files that correspond, and that's all they've got to look at. But it's a big list and ream of data, and they can compare them and see, do you know what, these are the same, and we've got no behavior involved in this, so why are you even talking to us? Could you talk to the checkout team instead and just tell them to change? So they do. And the profound step here is that We've got teams talking to each other about something they weren't talking to each other about before. And it's now just because we're starting to make those problems visible in the code. So checkout and accounts, they have a conversation. Can you provide us with this field? Yeah, we can do that. Could we get it directly from you? Why go through a fulfillment because they don't do anything? Oh, that's a good idea. Yeah, let's do it directly. And so they agree to do that, and they let the fulfillment PO know that they don't have anything to do with payment data anymore. And it's like, phew, I'm not going to break anything with payments again. And the beautiful thing is that this payment object that we were looking at earlier, it goes. Deleted code. Okay, so the PO is now thinking, I'm going to get my payoff here. Like, this is looking pretty good. I don't need these payment data objects anymore. They're gone. And it's not just that one payment data, actually, there was like, it referred to these other complex objects that sat underneath. And as they go through it, they start to think about, well, what else do we use? I mean, we get given all this article data. We can get rid of that because we know that the picking system in the warehouse actually goes and fetches that information again. We don't need it to come through with the order. All we need is the article ID. And that means we can get rid of all this other stuff as well. The customer contact info is shown in a UI, that's all. There's no behavior behind it, it's just shown in a UI. So why do we need to map all the attributes? Because as soon as we map all the attributes and there's a change, we've got to go in and make a change to the code. If we just saved that complicated thing as a string, it's a JSON string, we just serve it up to the UI, and then the UI can just evaluate the JSON string and do whatever it needs to do in the DOM. But we've made our code simpler. We've actually applied good encapsulation to say, well, I'm not fussed about this bit. All I need to do is get it and retrieve it, and I don't really care about how it's dealt with. Why Clojure? So a few years ago, and there's another talk by a chap called Shodan this afternoon who's going to go on about the same project, as it turns out, and only found that out today. But it's financial services related project about how to assess people for loan products, like what type of loan products are they allowed to have. It's sort of underwriting using complex policy to describe that. And it was a Java microservices system that was built to do this. But at the heart of the system, the policy engine, the thing that compared the application data to say whether you're allowed this product or not, was a Clojure. I know there's a bunch of devs brought in to maintain this. Well, we don't understand how this works. This is crazy. There's a million brackets everywhere, and it doesn't make any sense. So we kind of talked to each other about, well, do we rewrite this in Java? But there's compelling reasons for how clear the policy statements were in Clojure and how easy they were to read, that we thought, well, we think there's something here. Even though we don't understand how it's using that easy-to-read kind of data, it seems to work quite well. And the profound bit is that learning Clojure and how it treats data had a massive impact on our Java services. Because when you're just dealing with hash maps or hash maps that contain lists that contain hash maps, and in Clojure, the lovely idiom is that instead of sort of copying things into these slots, these destinations that you created, you just take this stuff, you don't really care about what the stuff is, and you inspect it. And you just sort of almost query it, like an XPath type queries to say, do you have these things, these values that I need? And if you do, I can get on with my job. And now this is starting to really sound like Postal's law in action, because it's being liberal with what you receive and then being very clear in what you send or what you produce. So my answers were as succinct as possible, which in this case was, yes, you can have a loan, no, you can't. But we went and changed all the Java to kind of behave in this sort of way and just solve our encapsulation problems. And we deleted 498 anemic data models because of doing that, and all their associated transformers, and their associated DTOs, and some what were called representational state objects that somebody had created. And we started to fly in terms of what we could deliver. It made a really big impact, a really big change on all of the work. Like, is this gateway in my fictional retailer, is it truly profound? Is it truly as amazing as making out? Well, not really. Is it technically perfect? No, it's not technically perfect. But all these things have been genuinely used to solve real problems on real projects. The key things are, it's it raised the visibility of the problems. It gave talking points for people to easily show to each other about what was going on or what was going wrong. Instead of teams talking to each other constantly, it meant that when they did talk to each other, the quality of their conversations was much higher. And crucially, it enabled like these incremental steps to change. So just to finish off with our fictional protagonists, where were they up to? Well, they're in much better shape. They've got lots of microservices now in the fulfillment team, and they're beautifully mapped, but they couldn't persuade the checkout team to get off this Swagger stuff and stop sending them all the data in the world. So they created proxies near their gateway that are actually like just the checkout proxy or the article proxy, and this stores the history of the data that they've been dealing with and manages that complexity of when to go and get the new things or when I'm getting things I've seen before, so I just want the history. So finally, I'm going to leave you with this lovely quote, which is that Lisp is worth learning for the profound enlightenment experience you'll have when you finally get it. That experience will make you a better programmer for the rest of your days, even if you never actually use Lisp itself. It's a chap called Eric Raymond, and he seems to be reasonably famous, and he did this essay called How to Be a Hacker, where he said these 5 languages, you need to learn them, but the last one was Lisp, and this is kind of the effect he said it had. That is all from me. I hope that was useful, and if you have any questions, I'm happy to take them.